case now, we are made to realize that the volume will be a variable and the radius will be a variable, whereas the h will remain constant. So here we write from V is equal to pi r square h, which is the formula for the volume of a cylinder. So instantaneous rate of change of the volume with respect to the radius this time around is what we are going to find. So according to the first principle of differentiation, this power we use to multiply, then we subtract 1 from this power. So what we are going to have now is going to be 2 times pi r raised to power 2 minus 1, then times the height. So this will reduce to 2 pi r raised to power 2 minus 1 is 1. So r raised to power 1 is r h. So what we have here now is the formula that we normally use to calculate the curved surface area. Curved surface area of the cylinder. Can you see now? So in conclusion, the base area of a cylinder is given by the instantaneous rate of change of the volume of that cylinder with respect to the vertical height. And also, the curved surface area of a cylinder, the formula for it is obtained by differentiating the volume of that cylinder with respect to the radius of the cylinder. Now, the last question, which is question number 2, let me put it here. The question says we should find the instantaneous rate of change of the area of a circle with respect to its radius. Now, this is normally the circle and this is the radius. You can see this is the area of that circle. So the circle may be increasing or decreasing based on if the instantaneous rate of change is an increasing rate of change or a decreasing rate of change. If it were to be a decreasing rate of change, that means the circle will become smaller and smaller. But if it were to be an increasing rate of change, that means the circle will become bigger and bigger. And the area of a circle is given as pi r square h, pi r square, where pi is a constant. It's a constant. That means it's not a variable parameter. So the variable parameter in this question, that means the variable I'm talking about quantity that changes in its own value. That means the area can change its own value and the radius too can change its own value. But pi, the value of pi remains constant. Now the question says we should find the instantaneous rate of change of the area of the circle with respect to the radius of that circle. So according to the first principle, the instantaneous rate of change will be changing the A, the R. So we use this power to multiply. That is 2 pi r raised to power. Then we subtract 1 from this power. That's 2 minus 1, which is 2 pi r. So this answer that we